Hello and good afternoon, CSI257 Section 847 students. For the first 8-week term of the spring 2015 semester, the Networking 3 course, part of the Cisco Networking Academy curriculum, being taught at Anne Arundel Community College. So today's PacketTracer tutorial is going to be on PacketTracer activity 5.1.5.7, where we're going to focus on some advanced OSPF features. Specifically, we're going to take a look at doing some layer 3 traffic engineering. We're also going to be adjusting some of the default OSPF timers, and we're going to look at setting up authentication. So let's go ahead and jump right in here. The scenario is that OSPF is already configured and running on all the devices. We're going to go ahead and manipulate some of this and adjust the bandwidth and enable authentication. So step 1, or part 1 I should say, we're going to test connectivity. So let's go ahead and hop on PC3, and it looks like we will need this table here, and let's test connectivity with the command prompt from PC3 over to PC1. So we'll say 172.16.1.2, and chances are the first ping might fail, and then we should have connectivity. And again, that first ping fails because it's got to ARP out and do that layer 2 to layer 3 resolution, or layer 3 to layer 2 resolution to get that MAC address, know where to go, and then it will succeed. And let's also ping PC2 is going to be 172.16.2.2. And again, same thing. Network is not local to us, so we're going to need to ARP for our default gateway. And then we get a reply back. Did we get a reply? Let me see if we got a reply. Okay, good. And then we get a reply back. The window's a little small there. So we have connectivity end-to-end with our PC. So the first thing that we're going to do here is we're going to go ahead and adjust the hello and dead timers. So let's go ahead on router 1, where they want us to start, and we're going to adjust the hello and dead timers. And the key thing here is that this, while not having to be done on every router in your environment, will have to be done on every router to which this router's connected, and the interface is the interface that's making that connection. So again, if we do this between router 1 and router 3, we don't have to do it between 1 and 2 or 2 and 3, as long as we aren't changing the values on those interfaces. So let's see, it wants us to do serial 000, so we're going to go from user exec into privilege exec, and then into global config, and we're going to say interface serial 000. And this is a nice activity. It'll actually sort of walk you through the steps, providing you with the commands. So we're going to change the hello interval, and the first thing we're going to do is we're going to change that to 15. So let's go ahead and quickly change our dead interval, OSPF dead interval, to 60, which is 60, which is 4 times the hello interval. And now let's do a do show IP OSPF neighbors. We should see the dead timer for our relationship with router, I believe 3 is out that interface, whichever router is out that interface. So here you can see the dead time as we watch it count down, right? It's well below 30, it's below 10, because again, we've changed the hello times. They no longer match. And so this adjacency on router 1 is going to go down, right? And so there it is. So now if I do a do show IP OSPF neighbors, you can see that we have a single neighbor. There we go. Let's make that a little larger. So we have a single neighbor right now, and the neighbor's neighbor ID is 192.168.10.10. Let's do a do show IP interface brief. And as you can see, we've got our gig 00 interface, and this goes out to our LAN segment. We've got our serial 000, which is what we just tweaked, 172.16.3.1. Now, here is often a confusing point for students and new learners. You'll notice when we did the show IP OSPF neighbor, what address did we see? And really, it's not an address, it's the router ID for the OSPF process. And it just so happens that this looks like it's probably the highest numbered up and up interface on router 2, which is who we were, I think who we just broke the adjacency with. So here's the actual address. It's 172.16.3.2, so it is router 2. And you can see that the router ID is being selected, and it looks like it's random. So let's take a look real quick at router 2, and let's see if that is in fact the case. And so that can sometimes be misleading when we see messages telling us adjacency with neighbor 209.165.200.225. Well, if you look at router 1 here, router 1 has no adjacency and is not connected into this network. However, that would be if this were the IP address, and it's not in this case. This is the router ID. And again, the router ID does not have to be an address that is in use. However, the format of the router ID is just like an IPv4 address. And even when you're dealing with OSPF v3 for IPv6, the router ID is still and will continue to be a 32-bit address in IPv4 format. So hopefully that's clear, right? That's the router ID. This is the actual address, right? So don't be thrown by this. So let's step over to router 2 here, and let's do a show run, or a show run. And we want to take a look at, and there's the address right there for serial 000. So that is the interface that we have just broken the adjacency with. So we want to see the OSPF configuration, and there you have it. When you look at the OSPF configuration on router 2, what do we see? We see that there is no hard-coded router ID configured. If I scroll back up here, we also notice that there are no loopback addresses configured. So there's no loopback address, no IPv4 loopback address. The router ID is not hard-coded. So if I do show IP interface brief, all we need to do then is take a look here to say, all right, what is the highest IP address on any up interface? And it's clear to see here that it's going to be this 209.165.200.225. And so that is why that address is showing up as the router ID. Again, to recap, we're seeing the 209.165.200.225 as the router ID because, one, there is no IPv4 loopback address from which OSPF can automatically pull and use as its router ID. Number two, there is no hard-coded router-ID value under the OSPF global configuration. And so then the third selection criteria is any IPv4 address, or I should say the highest IPv4 address off any interface that is in an up state. And so as a result, we end up with 209.165.200.225. If I were to type in show IP OSPF interface serial 000, you would see, there you have it. That is our router ID, and that is how the router ID was selected. And now, unlike the PacketTracer activity prior to this, which was 5.1.2.12, you'll notice that in 5.1.2.12 we were dealing with broadcast addresses, broadcast network types. And here with the serial links, we're dealing with point-to-point serial links. So when I do the show IP OSPF neighbor, show IP OSPF neighbor, you'll see that the priority will default to 0. There is no DR BDR election, and again, the reason for that is there's no need. These are point-to-point links. There will always and only be two endpoints on either side of the point-to-point link. So therefore, we don't need a topology sort of assist from the DR-BDR in order to keep the number of adjacencies in check. And so that's why you'll see the dash here. So it's full, right? But remember, there's no DR-BDR on point-to-point links, and that is also, for point-to-point links, the default priority will be 0. All right, so we've changed on router 1 the hello interval and the dead interval. So this is also a reminder that these values need to match in order for the adjacency not only to establish, but to be maintained. Because remember, we had full OSPF connectivity prior to me adjusting those timer values. All right, so after a short period of time, the connection with R2 is going to fail. And that short period of time is going to be 30 seconds plus whatever was left over from the hello packet time that we were expecting, right? So we're guaranteed it was going to be at least 30 seconds, and then depending on when we ran the command, will dictate the additional time. So it can't be any more than 40 seconds, that's for certain, but it'll be somewhere between 30 and 40. It all depends on where that dead timer is when you run that command. All right, so it's going to fail, and it did, and both sides of the connection need to have the same timers in order for the adjacency to be maintained. So adjust the timers on router 2. So let's come over here to router 2, go from privilege exec into global config, and then we're going to say interface serial 000, and I'm going to say IP OSPF hello timer, or hello interval, and we're going to set it to 15, and then the IP OSPF dead, let me fix that, OSPF dead interval is 4 times the hello interval, so we'll set it to 60. And so let's see what happens now when the hello packets are being sent every 15 seconds. What we should see is that, and let me do it, and it already came up. I was going to debug the adjacency there, but no need. So as you can see, the OSPF adjacency, the state machine ran through the different states, and now we're from loading to full. So now if I type do show IP OSPF neighbor, what do we see? So we see this is from router 2's point of view. He sees his 2 adjacencies, one out serial 000, the other out serial 001. You can see now the dead time, right? So it's no longer 30, or 40, I apologize. The dead interval is no longer 40, and why is that? Well, we've just adjusted it. We've made it 60 seconds. And so now what we should see is it should never go below 45. So it hits 45, and look at that, right back to 59. And it's actually, we're probably a little behind because it bumps it to 60, because that is our new dead interval. But only on that interface. And again, this goes back to the point where I had stated that you can manipulate these values, and as long as it's the same between the 2 routing peers that you're making the changes, if they've got other connections that go to other places in your OSPF domain, that's fine. They're simply going to have a different set of timer values, and that is not what I wanted to do. They're simply going to have a different set of timer values. You can see that our adjacency here out the serial 001 interface, that the dead time is 34 seconds, right? And we're probably not going to see that go below 30, right? And then it bumped back up to 40, and then it starts to count down. So we have 2 adjacencies, and so what I'm trying to say here is that the manipulation of the OSPF hello interval and the dead interval, it's mutually exclusive on the router interfaces, right? So if I do it on one interface on a router, on that same router, I don't have to make that change if I don't want to, unless I'm trying to change the interval with the router that's at the other end of that interface. And so in this case, router 1 and router 2, we have to make them the same, or else the adjacency is going to tear down, right? Okay, so let's go ahead and drive on here. So we're going to adjust the bandwidth, and this is typically one as well that will trip up new learners. So it says trace the path between PC1 and the web server located at 64.100.1.2. So let's jump on to PC1 here. And we'll pull this down so we can see. And I'm going to say trace RT to 64.100.1.2. And let's see where we go. So our first hop is to our default gateway, the 172.16.1.1. Our next hop is to 172.16.3.2. Now that should look familiar because that is the IP address right here on router 2's serial 00 interface. Our next hop is out to the internet, 209.165.200.226, right? So we're coming out here and then we hit the web server. So for traffic that's coming from PC1, and let's run this again to make sure that we get the results that we would expect. So look at that. Each time we're going northbound, right? So I'll say that we're going from PC1, we're going to be going from left to right. So we're heading eastbound, and then we head straight up to router 2. So then we go northbound, right? And it's the same path every time. So let's go ahead. And it says on R1, on the serial 00 interface, set the bandwidth to 64 kilobits per second. This does not change the actual port speed. And I'm going to talk about the use case for this because it's interesting that there's no additional sort of notation here to talk about what's the use case for this and when and why would you actually want to change the bandwidth setting on an interface. So again, the key though is that it does not change the actual port speed, only the metric that the OSPF process on router 1 will use to calculate its best routes. So let's take a look here at router 1. So let's go from user exec to privilege exec, and I'm going to type in show IP route. So you can, so you can see here that we are receiving an external type 2 default route. And so this is possibly coming from, and let's do a let's make sure we understand where that default route is coming from. And it is definitely coming from router 2. And if I were to do a show run, and we were to take a look, we should have a default information, and we do. So default information originate, and this is going to tie to the IP route statement, the default route statement to the quad zeros that's on this router. So this would need to be set, right? There would have to be a default route configured for this to be of any value. So once this is set though, what router 2 is now propagating into the OSPF domain and into the OSPF area is he's saying, hey, here's the default route for everyone in this area. And so back to router 1 is going to see that, and he sees it as, and that's what the asterisk is for here, that it is a default route candidate, and E2 is it is an external type 2. So if I were to type show IP OSPF database, we should see a type 5 LSA, and there it is right there. So we have a type 5 external link state LSA, right? And what's the link ID? It is our default route. Who is the advertising router? So what is the router ID for the router from whom we have learned this default route? And it's right here, 209.165.200.225. Okay, so this is why when you do the show IP route, that's why it shows up as an external type 2. If I scroll up just a little bit here, you'll see right here, E2, OSPF external type 2, right? And so that is our default route, and that is how we're learning about the default route. It's from router 2. So let's go back to the bandwidth. So we've seen where if we don't know where we're going, we're supposed to simply go out the default gateway here and head over to 172.16.3.2. But now we're going to make a change. Now what we're going to say is we're going to go from privilege exec into global config. I'm going to say interface serial 000. And let me make sure I get these values correct here. So we're just going to set the bandwidth to 64. Now again, actually, before I do this, and I'm glad I caught myself here. So if I do a do show interface on serial 000, what are we going to see here? So it's going to give us some information about the interface. It actually kind of scrolled right by what I was looking for. So it's going to give us some information about this interface. And one of the things it's going to give us is right here. It's going to give us the bandwidth in kilobits per second, right? So this is a serial link, and the max speed, and they do kilobits, it's 1.544 megabits per second, which is equivalent to a T1. Now that's equivalent to a full T1, right? And the bandwidth setting, when you do a show interface on an interface, the bandwidth setting that you see is the default for that interface type. So for a T1 link, the default, right? The default is going to be 1.544 megabits per second, or 1544 kilobits per second, as we see over here. And again, this is just simply a value that when the system boots, based off of whatever the interface type happens to be, that's what this value represents. So by changing this value, we're not actually changing the bandwidth or throughput capabilities of the interface. It will still have 1.544 megabits per second of bandwidth. Even if I drop it to 64K, it still has this capability. However, OSPF, remember, we can tweak an interface if we do OSPF cost and then some number. We can change the likability or the preferability of the interface, the feasibility of the interface, by tweaking its cost, right? And again, with OSPF, the higher the cost goes up, the less preferable that path is. And so this is one way that you can make that change. The other thing that we can do is we can tweak the bandwidth setting. Now, I can honestly say that in modern networks, this is probably the preferred way to go about it, because in most modern networks, you're not going to find a whole lot of serial connectivity, right? So not to say that it doesn't exist, right? There is a use case for it, but by and large, the IP-OSPF cost is probably going to be what you're dealing with in larger enterprise networks. And so this leads us to the use case. So what is the use case for the bandwidth command? And whoops, there we go. And let me get rid of this color here. Let's change this to black. There we go. So what is the use case for the bandwidth setting? And this is something that I actually get to deal with on a daily basis, right? And it's really interesting. So if you do have serial links in your environment, you'll see that the interface defaults to the speed of a T1. And a T1 is 1.544 megabits per second. However, you can have what we refer to as fractional T1s. And what that means is I could have a T1 that's, let's say, 512 kilobits per second. Now, it's still going to use this card, and the setting by default is still going to say 1544 kilobits per second, because again, for this interface type, that is the default, and that's where that value comes from. But in the real world, if I'm stepping down my T1 on this interface to a fractional, and let's walk this down, I could say it's 512, I could even use 256 kilobits per second, I could say it's 128 kilobits per second. In our instance here, 64 kilobits per second, and I've seen them as slow as 56 kilobits per second, right? So just right here, we've got how many different speeds? We have 5 different fractional speeds. There certainly could be more, but we're looking at 5 right here. And so if I have OSPF running in my environment, and OSPF thinks that all of the interfaces are defaulted to 1544 kilobits per second, it's going to treat them all the same. So when it's trying to determine, do I jump over the 512 kilobit per second link, or should I use the 56 kilobit per second link? This is where the bandwidth calculation or the bandwidth manipulation of the OSPF decision process comes into play. Because again, when I change that setting, that bandwidth setting right here, I'm not actually taking away any bandwidth that the interface has. What I'm doing is, I like to think of it as you're right sizing, right? So I am right sizing that interface by setting the bandwidth statement, DTH, by setting the bandwidth statement and stating bandwidth 56 if it's 56K. So that way OSPF, when it's making its calculations, it looks at that bandwidth value and says, oh, okay, so even though it's a serial link, it's not actually a full T1 link. It's a fractional link, and in our case, let's say it's 56K, right? And when I do my calculation, obviously this link right here is going to receive the check because it's far faster, almost by a factor of 10, short of a factor of 10, but pretty close, right? So you could say that this link right here should be 10 times more preferable to have our traffic transit this link than to transit the slower link. And so by setting the bandwidth, all we're doing is right-sizing the environment, right-sizing the environment so that the interface in the router actually reflects the true capabilities of that interface. And so that's all the bandwidth command does. And I know a lot of new learners, and I just got a question from a student last night with a little confusion, wondering, curious about the fact of, so does it change the bandwidth on the interface or does it not change the bandwidth on the interface? And, because you're going to see this value change, so what exactly does that mean? And so this is really all it means. And these right here are your use cases. And so I deal with a lot of satellite imagery and, small, little chunks of data that float all over the place between multiple sites. And we have links that are 56K, we've got 64K links, we've got 128K links, we've got 256. And in every instance where we're running OSPF, we right size that interface setting on that router so that OSPF can make an informed, intelligent decision to route the traffic. Okay, so let me come back over here. Let's clear, let's clear, and that is not what we wanted. That is what we wanted, and let me drop that down. I want the desktop. Sorry about that. Okay, so we are back, right? And now let's go ahead, and we saw that it was 1544, sorry, kilobits per second, which is 1.544 megabits per second. Now let's jump in. Let's make sure I'm in that right interface. I believe I am. All right, so we're going to say bandwidth, and we're going to drop it all the way to 64. So in effect, what we're saying is this interface right here, when OSPF looks at that, it's going to think that it's 64 kilobits per second. And it could be, right? It could be. However, this guy right here is going to be seen as 1.544 megabits per second. And so let's see what happens when we make this change to the interface. So I type in bandwidth 64. It says trace the path between PC1 and the web server located at 64.100.1.2. Notice the path from PC1 is redirected through R3. So if I were to type in do show IP route now, where do we want to go now? Now we want to go across over to the 192.168.10.6. So it's telling us the default route. We're better off heading over this way, and to get to that network, right, the 192.10.6, we're going to transit this link right here, which is and I actually wrote on top of it, it's 192.168.3.10. So now let's pull PC1 up again, and let's run the trace command again. And you can see our first hop is the default gateway, which is router 1. However, router 1 now believes that the link serial 000 is far less capable than the link serial, I believe it's 001 maybe. So the link that goes over to router 3. So now router 1's view of that serial 000 interface is far less preferable. In fact, you'll notice that when we were on R1, that is not the default route that gets installed into the routing table. The best route gets installed into the routing table, and that is going to be from router 3 out the serial 001 interface, right? And we saw that with our trace route results. Okay, so we're going to leave that set the way that it is, and let's come into the authentication piece. So authentication on all serial interfaces. And this process is the same even if it was Ethernet interfaces. So let's go ahead and we're going to set up authentication between R1 and R2. So let me pull this back a skosh. All right, so there we go. So on router 1, we're going to go into do show run. I believe it's OSPF process ID 1, and it is. So I'm going to say router OSPF 1. And I'm going to go ahead and type in here area 0 authentication, and we're going to use message digest, right? So I set the message digest for area 0, right? Enabling it for area 0 interfaces. Now I'm going to go ahead and go into the interface on which I want to configure this, and I'm going to say IP OSPF message digest key 1. We're going to use an MD5 hash, which is the most secure way to do authentication. And real quickly, remember there are 3 types of authentication. And really there's 2, but for whatever reason, you'll always see it referred to as a type of authentication, but it's referred to as null authentication, N-U-L-L. So, and null authentication means is that there is no authentication. Again, they still count it as a type of authentication. It just means there's no authentication. So it's null. Then you have simple password authentication, which the password's going to be passed back and forth in plain text and can be easily picked up with a sniffer. And then finally, you've got the third type of authentication, which is MD5 authentication with a message digest key or a hash. And this is the most secure way to do things today. So let's go ahead and rerun that command, and the password is going to be R1 to R2. Now, you can see that we've added authentication, and as a result of this, all of our neighborships have gone down, because this is very important to understand. This command right here that we ran under the OSPF router config area, when I said area 0 authentication message digest, this actually tells the interfaces that are in area 0, every interface in area 0, you are now doing message digest authentication, which is why, and you'll notice here, I hadn't even typed it in on the interface yet, and we are dropping our adjacencies. The dead timers are expiring because that command right there is going to enable authentication on every interface in area 0 as soon as I hit enter, right? So this is not something that you would want to do in the middle of a production day, or else it could be a resume generating event, right? So right now, if I do the do show IP OSPF neighbors, I don't have any, right? Because my adjacencies are down with everyone. So let's come over here and take a look. And after the dead interval expires, the adjacency between R1 and R2 is lost, and that we saw that. And R1 and R3 is also lost, so we saw that. So let's go on to router. It wants us to do, what's it asking us to do here? Oh, okay, so it wants us to set it up between R1 and R3 right now. And then we're going to do R. So let's go ahead and we'll finish up here. So I'm going to say interface serial 001, and we're going to use that same command that we just ran, except it's going to be R1 to R3. And so let's jump over to router 2 and let's set up authentication as well. So we're going to go from user exec into privilege exec, into global config, into the router OSPF, and the process ID is 1. And we're going to say we're going to say area 0 authentication message digest. So as soon as I do that, if router 2 had any adjacencies, and he should with router 3, if I do a do show IP OSPF neighbors now, look at that dead time, and there it goes. And you can actually watch it in real time as it counts its way all the way down to 0. Now I could save this. Let's see if I can do it quick enough. Int, and I can't even remember serial 001. Serial 001. And actually this is to router 3 who doesn't have it configured yet. So I'll try it on router 3 to get it in there before that right there happens. Before it goes down. We'll see if we can save it. So I'll say int serial 001, and then let's add in our OSPF message digest key, which is going to be key number 1, MD5. And it's going to be R1 to R2. Now, the key, right, that we have here, this needs to match the R1 to R2, because that is the password that we're using to bring that adjacency back up. So when I type in IP OSPF message digest key 1 MD5 R1-R2, what we should see here is at the next hello interval, this interface should come back up. So while that's waiting, let me jump into interface, and actually that is incorrect. So I just realized that I'm in serial 001, which is going to be R2 to R3. And serial 000 is going to be, where are we at? There we go, R1 to R2. All right. So we've got the interface configured to router 3 and router 1 taken care of. Let me do a do show IP, interface brief to make sure we are serial 001. We are. Okay, great. So now if I do a do show IP OSPF neighbor, all right, so my adjacency with router 1, with router 1 is back to the full state, and we are up and operational here. What if I were to type do show IP OSPF interface serial 000? So this gives us some interesting information as well when we look at the OSPF interface where OSPF is running. So again, we're point-to-point, priority is 0. Remember, we made some adjustments to the hello and the dead timers, right? And most importantly, right here, your digest authentication enabled youngest key ID is 1. And so I'm kind of waiting to get to R3 to sort of demonstrate what happens when the keys don't match. So remember, the passwords have to match, but do the keys have to match? Well, we're going to find out right now. So we're using key ID 1. Now, router 3 is the only router that's left to be configured with authentication. So let's jump over here onto router 3. And for those of you that are interested, I actually have an additional video, and I believe it's under the CCIE playlist section, where I go into even greater detail on how to set up authentication, the different ways that you can set up authentication, and when and why you would want to use that. So we're going to go on router 3 from user exec to privilege exec, and then into global config. And I'm going to go into router OSPF 1, and I'm going to say area 0 authentication message digest. And so let's go ahead and see if I can debug this while we're doing this. So if I were to say debug IP OSPF, and let's say adjacencies, and I'm going to do events as well. which is pretty much all I can. Perfect. All right, excellent. So this is exactly what I was looking for. So we have the OSPF Area 0 authentication set, but what is it saying, right? So I'm sending with my youngest key, which is the newest key, right? The most recent key is key 0 because I haven't configured any keys. So it's just sending key 0. Now, if you look at the message, it says receive packet from 192.168.10.5. It says mismatch authentication key, no message digest key 1 on the interface. So let me go ahead now, and I'm going to go ahead and type in here, go into global config, and I need to get on the interface. So we'll say interface, and it's going to be actually both interfaces, serial 000, do show IP interface brief. And I know I've got some messages scrolling there, so bear with me. So we're going to go ahead and say IP OSPF authentication, or I'm sorry, message digest key. We're going to set the key right on the serial 000 interface, and this is going to be R1 to R3. So as soon as I type that, right, I've set that on the serial 000 interface, which should be over toward, yep, there you go. And so the adjacency has come up, right? However, we're still going to be receiving messages telling us that, and I apologize, 1 second. Let me pause here. All right, so let's pick up where we left off prior to the phone ringing. And here's where we're at. We now have the key, which is actually being used between router 3 and router 1, and that's working great. However, we're still receiving a message here about the key being exchanged between router 3 and router 2. It says mismatch authentication key, no message digest key 1 on the interface. So let me go ahead, and what we're going to do is I'm going to start the debugging on the router 2 side. So we're going to say debug IP OSPF adjacency and debug IP OSPF events. And so we're going to leave that on the router 2 side. And you should see here that we're also going to be receiving the messages telling us it's sending the youngest key, and we have a mismatch. And so then I'm going to turn the debugging off here. So we'll do a UAll. There we go. Okay. So the final piece of the configuration here is going to be to set up the interface, do show IP interface brief on the 192.168.10.8 network, which is serial 001. Now I'm going to put in here IP OSPF message digest key, and the key can be any number from 1 to 255. So I'll say 2, and then I'm going to say MD5, and then we need to put in what the password is going to be. So R2 to R, or the hash, R2 to R3. Make sure I got that right. R2 to R3. Did I use that earlier? I think I did. All right. So I've put the correct key in there. The correct password's been placed in there. I'm going to come over here and let's see what we see now. We'll take a look at this. So here we have the error message where it says that no message digest key 2 on interface. So router 2 is saying, hey, my key ID is key 1, not key 2, and I'm receiving key 2 from you. So again, not only do the passwords have to match, which should be obvious, but the key IDs also need to match in order for the authentication to work. So let's go ahead and sort that out. So I'll come back here. I'm going to say no IP OSPF message digest key, and we're going to say key 1, and we're going to make that change and look at that right away. Everything went up. So let's do a do show IP OSPF interface, and this is going to give us the information about our interfaces here. You can see message digest authentication enabled, and which interface is that? It's gig 00. Hold on. So let's narrow this down. So let's say do show IP OSPF interface serial 000, and there we go. And the youngest key is the key with the ID of 1, right? That's the most recent key. Okay, so that just about does it. Can we ping the web server? So we'll try from PC1 here. Let's go ahead and pull this up, And let's see if I type in ping 64.100.1.2, and we've got full connectivity. However, we never took that bandwidth statement off there, so let's do a trace RT for trace route, and let's see 64.100.1.2. We should still be jumping over, and we are, over from router 1 to router 3, and then to router 2, and then out to the internet. All right, well, this wraps up PacketTracer activity 5.1.5.7 on configuring OSPF advanced features. We took a look at the bandwidth setting, and hopefully you've got a much better understanding of that based off of the description here as to why and when you would want to do something like that. We also adjusted the hello interval and the dead interval and watched as adjacencies literally withered on the vine and then went into a down state when the dead interval time had been reached. And finally, we did some OSPF authentication. And let me get rid of that. We did some OSPF authentication with MD5, remembering that there are 3 types of authentication, although the first one is always one I question why it's included, but it's null authentication, which means no authentication or nothing's being exchanged. There's simple password authentication, which means that it's clear text password that can be easily picked out. And then finally, you have MD5 hash password authentication, which is the most secure way to do things today. So that wraps up this video. I appreciate your time and you watching, and hopefully you've got a much better understanding of these advanced OSPF features. All right, have a great week, and I will see you in class on Saturday.